This is Spacetime, Series 24, Episode 46. Coming up on Spacetime. History in the making, the first flight of an aircraft on another world. The dead star that's a sign of things to come. And NASA's SHIELDS mission to explore local interstellar space. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
NASA's made history with the first flight of an aircraft on another world.
They are taking a look at the data just starting to flow into the Deep Space Network antenna on Earth.
The Deep Space Network is our giant communications network that...
This is downlink. Early indications, data products look nominal.
So our downlink lead just announced that data products had just started to arrive and that they look nominal, which is a good indication. So the helicopter flew earlier, and similarly, whenever we send data, it's the same process where there's going to be a delay of when we run the data and then when it hits Earth. So it's about 4 hours from when something is executed to when we receive it. For larger files, though, sometimes that can take longer. So it all depends. But today we'll be receiving still images of the helicopter. The helicopter is equipped with two cameras. One is our onboard navigation camera, and that's the image that we'll receive tonight. And that's going to be a black and white image that's pointed straight down at the Martian surface and will hopefully be showing us hovering above it. Our second camera is our return to Earth camera, and that's our higher resolution camera that is a color photo and shows more of the Martian horizon snapshot, the beauty shot, if you will. That image will be utilized for future flight missions.
This is downlink. Data products appear to be in. We will begin processing shortly. We are beginning to fetch data from Mars 2020. This is downlink. We have pulled in data products from Mars 2020, confirming we received Mars 2020 telemetry, confirming that we received Mars 2020 events, confirming that we received helicopter data products, confirming that we have data products, confirming that we unpacked image and 1 Hertz data. This is downlink. We have successfully ingested 1 Hertz data, confirming that we have helicopter data products, helicopter telemetry, helicopter events, confirming helicopter file listing, confirming expected boot counts. This is downlink, confirming battery data has been received.
Rotor motors appear healthy. Swash plate servos appear healthy. Overall actuators appear healthy.
Confirming thermal report generation, confirming analog report generation, confirming telecom report generation. This is downlink, handing off to flight control for telemetry analysis.
This flight control, confirming that we have EVRs from Ingenuity. Ingenuity is reporting having performed spin-up, takeoff, climb, hover, descent, landing, touchdown, and spin down. Altimeter data confirms that Ingenuity has performed its first flight of a powered aircraft on another planet.
So the image we're looking at on the screen is the image from our onboard navigation camera showing us hovering above the surface of Mars. How incredible! Everyone is super excited.
So I would say it's a success.
The United States Space Agency's Mars Ingenuity rotorcraft successfully lifted off from the floor of the red planet's Jezero Crater, climbed to an altitude of 10 meters, then maintained a stable hover for 30 seconds, and then safely landed again. The historic 39.1-second flight, demonstrating that powered, controlled flight on another planet is possible. But it follows a week of high drama, with mission managers at NASA's Jet Propulsion Laboratory in Pasadena, California, forced to upload new software before the 1.8-kilogram autonomously controlled solar-powered helicopter could fly. NASA received telemetry of Ingenuity's historic flight by way of the 6-wheeled Mars Perseverance rover, which had transported the tiny drone on the 7-month, 278 million kilometre journey from Earth. Ingenuity's maiden demonstration flight was autonomous, piloted by onboard guidance, navigation and control systems running algorithms developed by the team at JPL. Because commands had to be sent to and returned from the red planet over hundreds of millions of kilometres using an array of orbiting satellites in NASA's Deep Space Network, and its flight wasn't observable from Earth in real time, Ingenuity could not be piloted directly by way of a joystick. As a technology demonstrator, the 49cm tall tissue box-sized fuselage of the Ingenuity Mars helicopter contains no scientific instruments. Instead, the rotorcraft is simply designed to demonstrate whether future exploration of the red planet could include an aerial perspective. Still, the first flight was full of unknowns. See, although the red planet is significantly smaller than the Earth and therefore has a lower gravity, just 1/3 that of Earth, which is good news, it also has an extremely thin atmosphere, with only 1% the surface atmospheric pressure of Earth. And that's bad, because it means there's relatively fewer air molecules for Ingenuity's twin 1.2-metre wide rotor blades to bite into in order to achieve lift. The helicopter contains a mixture of unique components specially built for the job, as well as off-the-shelf commercial parts, many from the smartphone industry, which are being tested in deep space for the first time on this mission. Parked some 64 metres away during Ingenuity's historic first flight, the Mars Perseverance rover acted not only as a communications relay link between the helicopter and Earth, but it also chronicled the flight operations with its cameras.
Perseverance images showing us grounded at first. It's actually a video, which is great. It's grounded at first and then shows us hovering our 3 meters above the Martian surface and then touching back down. It's amazing, brilliant.
Vision from the rover's Mastcam Z and Navcam images providing additional data on the helicopter's flight. Perseverance touched down on the red planet with Ingenuity attached to its belly on February the 18th, and the helicopter was deployed onto the Martian surface on April the 3rd. Ingenuity is now just over halfway through its 30-sol Martian Day flight test window. So after analysing all the data and imagery from the first flight, mission managers quickly undertook a second, slightly longer test flight 4 days later. The 52-second sortie saw Ingenuity climb to an altitude of 5 metres, hover briefly, then tilt and fly sideways for just over 2 metres. It then came to a stop, hovered in place again, and made a series of turns to point its camera in different directions before heading back and landing at its original takeoff point. At least 3 more test flights are planned, and mission managers are carefully studying their telemetry to determine how to proceed. Autonomous drones like Ingenuity are expected to play a major role in future planetary exploration, scouting ahead of rovers to find the best routes and most interesting geology, and undertaking aerial mapping surveys. NASA's already preparing to send a much larger rotorcraft lander called Dragonfly to Saturn's moon Titan, reaching the strange methane and ethane-covered world in 2034. This is Spacetime. Still to come, the dead star that's a sign of things to come, and NASA's SHIELD's mission to explore the local interstellar environment. All that and more still to come on Spacetime. Astronomers have discovered their first pulsar using the Murchison Widefield Array radio telescope. Murchison is a precursor for the multi-billion-dollar Square Kilometre Array radio telescope project, and researchers say that this discovery is likely to be a sign of things to come. Pulsars are rapidly spinning neutron stars, the super-dense stellar cores of dead stars far more massive than the Sun that have gone supernova at the end of their lives, exploding in blasts so powerful they briefly outshine an entire galaxy. As pulsars rotate, they send out powerful beams of energy, sweeping across the cosmos like a lighthouse beacon. If the Earth just happens to be in the line of sight for one of these beams, the neutron star appears to blink off and on, often dozens of times a second. Nick Swainston, from the Curtin University node of the International Centre for Radio Astronomy Research, discovered this neutron star pulsar while processing data collected as part of an ongoing pulsar survey. Pulsars are unique cosmic laboratories, containing more mass than the Sun, packed into an object just 20 kilometres or so wide. In fact, just a spoonful of pulsar material would weigh literally millions of tons. They are the densest objects in the universe other than black holes. And they have some of the strongest known magnetic fields, 1,000 billion times stronger than what we have on Earth. Pulsars can be used by scientists for many applications, including testing the laws of physics under extreme conditions, allowing scientists to undertake experiments that simply couldn't be done in laboratories on Earth. So, finding pulsars is one of the key science drivers for the Square Kilometre Array project. What will be the world's largest radio telescope, stretching across 2 continents, covering outback Western Australia and Southern Africa. So far, astronomers have discovered around 2,800 pulsars in total. And this discovery hints at a large population of pulsars waiting to be found in the Southern Hemisphere. The newly discovered pulsar was detected more than 3,000 light-years away in a region south of the galactic plane. It's spinning once every second, which is incredibly fast compared to regular stars and planets, but fairly normal in the world of pulsars. Significantly, this discovery was made after looking at just 1% of the data collected in the Pulsar survey. Swainston says this discovery only scratches the surface, and once the project is at full scale, astronomers expect to find hundreds of pulsars in coming years.
Doing surveys with telescopes is always a big undertaking, takes lots of processing, and you have to really start to understand your telescope. So we're really happy that this was our first one. One of the reasons we think that other telescopes haven't detected this is because we are a low-frequency telescope, so it means we're sensitive to different types of pulsars, and we can observe for a bit longer. So the longer you observe, the bit more sensitive you are. So there are still more pulsars out there for us to discover.
Where exactly was this one found?
This was discovered pretty far off the galactic plane. So most pulsars along the galactic plane where there's more matter. This one was fairly far off. So it was in this part of the sky where we haven't found many pulsars. So that in itself was a bit exciting.
And does it have a name?
Well, it does. So it's called Pulsar J0036 minus 10035. Unfortunately, I can't name it after myself. It's just after the position in the sky.
Shucks. Some 2,800 pulsars thereabouts have been discovered so far. Do we know a lot about them? Well, we do know how they're made, but that's really about it, isn't it? We don't really know much about these super dense objects.
Yeah, I agree. It's been about 50 years since we discovered the first one, but they're very difficult to understand because they're these extremely dense, these really strong magnetic fields, very unlike anything we have at Earth. So it's this new part of physics that we're always trying to understand. And each pulsar is a bit unique, has different properties and emits in different ways. So the more we find, hopefully the closer we'll get to understanding all these complex physics.
It's really weird. We don't even know what they're really made of, do we?
What pulsars are made of?
Yeah, we've got a rough idea. We know there's protons and electrons coming together to form neutrons, but it's the state they're in that's so interesting.
Yeah. So it's a plasma, which is the fourth state of matter. And yeah, it's really complicated. Like there's all these weird things. Like for example, pulsars often glitch. So we think of them as regular clocks, but sometimes the clocks sort of change how quickly they go very suddenly. And we think that's because of the plasma physics. And we're starting to understand that. But like once again, it's very new physics that is difficult to comprehend.
And what about the beams that they create? The thing that makes a pulsar so different from any other type of neutron star is these electromagnetic beams that they shoot across the cosmos like lighthouses. We know where they're generated, just above the surface, near the magnetic poles, but do we know exactly how they're generated? That's still a bit of a mystery too.
Yes, it's one of perhaps the most difficult problems we have is trying to work out the emission. There's lots of different, what we call emission models, so sort of theories about how they emit, but every single one has problems because there's lots of different types of pulsars, and your model has to explain all these different types of emission, and there's no single model at the moment that can.
Are all neutron stars pulsars, or do neutron stars stop spinning occasionally?
We think that pulsars do eventually die after millions of years. They no longer have the power to produce radio emission, but it's hard to tell if a neutron star is a pulsar or not because it might be a pulsar and just not pointing towards us. It might be pointing away from the Earth, so we're not able to see it.
The Murchison Widefield Array is one of the Pathfinder telescope projects for the Square Kilometre Array. And that's what this is all about. This is telling us that we've found this pulsar, we're going to find more of them in this current survey, and imagine what we're going to find when the SKA starts up. How's that all going?
Yeah, well, exactly. So the Murchison Widefield Array is, to an extent, just a smaller, cheaper version of the SKA. So it is very promising that we're starting to learn how to process such large data quantities, and we are finding pulsars. But the SKA is getting really exciting. We're hoping to start building it at the end of this year, and we're predicted to discover another 6,000 pulsars, so almost triple the amount of pulsars we currently know.
That's Nick Swainston from the Curtin University node of the International Centre for Radio Astronomy Research. And this is Spacetime. Still to come, NASA's SHIELDS mission to explore local interstellar space. And the Expedition 64 crew returns safely to Earth aboard their Soyuz spacecraft. All that and more still to come on Spacetime. 18 billion kilometres away, more than 4 times the distance from Earth's orbit to that of Pluto, lies the boundary of our solar system's magnetic bubble, the heliopause. Here, the sun's magnetic field, stretching through space like an invisible cloud, fizzles out to nothing, and interstellar space begins. Astronomers know very little about what lies beyond this boundary. Only the Voyagers 1 and 2 spacecraft have ventured this far, and they're using technology dating back to the 1970s. Fortunately, bits of interstellar space can come to us, passing right through this border and making the way into the inner solar system. And a new NASA mission's about to study these interstellar particles, in the process telling astronomers a little bit more about the region where the solar system ends and interstellar space begins. The mission is called the Spatial Heterodyne Interferometric Emission Line Dynamic Spectrometer, or SHIELDS, which is about to launch from the White Sands Missile Range in New Mexico aboard a suborbital sounding rocket. Right now, our solar system is adrift in a cluster of clouds, in an area cleared out by ancient supernova explosions. Astronomers call this region the local bubble, an oblong plot of space about 300 light-years long within the spiralling Orion arm of our Milky Way galaxy. It's a region containing not just our Sun and solar system, but hundreds of other stars and systems. Our solar system, orbiting the Sun and its magnetic bubble the heliosphere, is travelling through the local bubble at some 23 kilometres per second, and interstellar particles are constantly pelting the nose of the heliosphere like raindrops against a windshield. In fact, the heliosphere is very much moulded by its surroundings, compressed at some points of pressure and expanding at others. We think it looks like a giant twin-tailed comet, or more likely a croissant. But exactly how and where the heliosphere's lines deform is uncertain, and the SHIELDS mission will provide some clues about this, as well as the nature of the surrounding interstellar space outside it. SHIELDS mission principal investigator Walt Harris from the University of Arizona in Tucson says this boundary region and any deformities in it is what the SHIELDS mission's telescope will explore. Harris's team launched an earlier iteration of this telescope as part of a HYPE mission back in 2014, and after modifying the design, they're ready to launch again. SHIELDS will measure light from neutral hydrogen atoms from interstellar space. Neutral hydrogen has a balanced number of protons and electrons. Protons being positively charged and electrons negatively charged, they even each other out, hence the term neutral. Neutral atoms can cross magnetic field lines, so they sweep through the heliopause and into our solar system nearly unfazed, but not completely. And it's the small effects of this boundary crossing which are key to SHIELDS' technique. Charged particles flow around the heliopause, forming a barrier, and neutral particles from interstellar space need to pass through this gauntlet, which alters their paths. And that's where SHIELDS comes in. It's designed to reconstruct the trajectories of these neutral particles to determine where they came from and what they saw along the way. A few minutes after launch, SHIELDS will reach the peak of its altitude about 300 kilometres above the ground, far above the absorbing effects of Earth's atmosphere. Pointing its telescope towards the nose of the heliosphere, it'll detect light from arriving hydrogen atoms. Measuring how that light's wavelength stretches or contracts reveals the particle's speed. SHIELDS will produce a map reconstructing the shape and varying density of matter in the heliopause. Harris hopes the data will answer tantalizing questions about what interstellar space is like. Right now, astronomers think the local bubble has just 1/10 the average gas density of the rest of the interstellar medium in the galaxy's main disk. But scientists don't know if matter in the local bubble is distributed evenly or whether it's bunched up in dense pockets surrounded by nothingness. Astronomers also don't know much about the galaxy's magnetic field, but it should leave a mark on our heliosphere which SHIELDS can detect, compressing the heliopause in a specific way based on its strength and orientation. Learning what our plot of interstellar space is really like would be helpful in the distant future. See, our solar system is really just passing through this current patch of space. In about 50,000 years from now, it'll pass out of the local bubble. But what will it pass into next? This is Spacetime. Still to come, Expedition 64 returns safely to Earth after 185 days in orbit, and later in the science report, researchers successfully grow human primate hybrid chimeric embryos. All that and more still to come on Spacetime. 3 members of the Expedition 64 crew have returned safely to Earth following half a year aboard the International Space Station. They had launched 185 days earlier, back on October the 14th, from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan. The trio's Soyuz MS-17 spacecraft parachuted down under clear blue skies under the Kazakhstan steppes.
Soyuz Commander Sergei Ryzhikov maintaining a running dialogue with flight controllers at the Russian Mission Control Center, reporting on Soyuz systems, the crew putting their visors down on their helmets. This in preparation for the pyrotechnic separation of the 3 sections of the Soyuz, the topmost section called the orbital module, and the lower section, the instrumentation and propulsion module. They will be separating soon. That will allow the descent module to fly on its own with its computers honed in on the landing site about 91 miles to the southeast of the town of Jezero.
Favorite, Mission Control. Favorite here. We hear you through the noise. How do you read us? We have you loud and clear. Copy.
This is Mission Control Houston. Based on the last report from Sergei Ryzhikov, everything going very well on board the Soyuz MS-17. The next major event coming up in about 11 minutes, the separation of the 3 sections of the Soyuz, as the descent module with the 3 crew members strapped inside will then fly free with its onboard computers targeting the landing site to the southeast of the town of Jezero. The orbital module and the instrumentation and propulsion module separate from the descent module that then enters the Earth's atmosphere, building up heat, repelling the heat through its heat shield before the deployment of a drogue chute and then the large main chute. And with the completion of the deorbit burn a short time ago, the Russian Mi-8 helicopters are all airborne en route to the landing site. This is all very carefully choreographed and timed. The separation of the 3 sections of the Soyuz will occur at an altitude of about 87 miles. All done by automatic commanding from the onboard computers, firing pyrotechnics to enable the 3 sections to separate from one another. In the center section or descent module, Soyuz Commander Sergei Ryzhikov flying under the call sign of Favorite. In the center seat, flanked on his left by Sergei Kud-Sverchkov and on his right by Kate Rubins. The landing site coordinates calculated by the Russian flight control team in Korolyov call for the Soyuz to be targeting a landing spot at 47.2 north, 69.3 east. The weather reports indicate clear skies, very light winds, temperature around 64 degrees Fahrenheit. The reports now in from the Russian Mission Control Center that module separation has occurred on time. The Soyuz descent module with the 3 crew members strapped in their seats in their Sokol launch and entry suits are barreling toward the landing site southeast of Jezero. The next major event some 3 minutes from now, when the vehicle enters the Earth's atmosphere at an altitude of 100 kilometers. Once the Soyuz approaches the landing site some 15 minutes before touchdown, there is a intricate parachute deployment sequence that is triggered by a barometric pressure sensor when the vehicle is about 41,000 feet above the ground. At that point, the main parachute cover is first jettisoned by pyrotechnic devices and springs. This will pull out a pair of extraction chutes, which in turn pulls out the drogue chute, which in turn pulls out the main parachute. It takes about 20 seconds for all of this to happen. When the atmospheric pressure that is measured around the Soyuz reaches the proper levels, a barometric pressure sensor starts a timer that triggers most of the remaining events in the landing sequence. At an altitude of about 18,000 feet off the ground, commands are issued to jettison the heat shield and to open valves to vent hydrogen peroxide, fuel for the entry control thrusters, and oxygen in the life support system tank, so that the vehicle can be safed for landing without an abundance of hazardous gases remaining in the tanks when the soft landing thrusters fire just milliseconds before touchdown. The Soyuz now beginning to enter the Earth's atmosphere. This will mark the first effects of Earth's gravity against the bodies of the 3 crew members for the first time in 185 days. We're inside 23 minutes until the anticipated touchdown of the Soyuz to wrap up a 78.4 million-mile mission. The three crew members in the descent module of the Soyuz MS-17 should be seeing the first effects of plasma, a fireball building around the spacecraft, where temperatures rise to about 2,500 degrees, ablated by the Soyuz heat shield. The Soyuz computers also providing entry guidance to fine-tune the path of the spacecraft toward the landing site on the steppe of Kazakhstan. The spacecraft and the crew members should be emerging from this plasma regime in about 3.5 minutes or so.
MCC Moscow.
Flight controllers at the Russian Mission Control Center attempting to contact the Soyuz, but as expected, communications not expected to provide a response as the Soyuz descends in the heat-peaking regime during its entry back to Earth. Touchdown expected about 18.5 minutes from now. The Soyuz spacecraft should be emerging from this plasma regime about a minute from now, and as it approaches the landing site, communications should be established through the search and recovery forces in the Antonov 26 fixed-wing aircraft around the landing zone, serving as a command and control relay station.
Favore, we copy you.
Вход пассажира 3433, перелет до гроба 9 секунд.
Принято, плюс 9 секунд.
We confirm atmospheric re-entry with a plus 90 mid.
Принято, самочувствие.
Отлично.
Давление лица.
10. How are you feeling? Great. What's the pressure?
Принято, 772.
It is 772. Copy. 772 is the stop pressure. What's the max G load? It was 3.8. Maybe 395. We copy. 395. Please make sure that the ODF procedures are secured. And once the seats are primed, make sure that you put the translation and the rotational hand controllers in the corresponding position. Discrete number is about 1 and integer 0.1. And the integer is 10, plus 10, affirmative, plus 10.
This is Mission Control Houston. Almost like clockwork, communications reestablished between Mission Control in Korolyov and Sergei Ryzhikov, the Soyuz commander. The crew now out of the plasma regime. Atmospheric entry was a nominal occurrence, and we're standing by now for the opening of the parachutes, the command to begin the parachute deployment sequence. Parachutes should have been commanded to deploy by now. This is Mission Control Houston and Soyuz MS-17 under its main parachute. The white smoke is the nominal venting of hydrogen peroxide and oxygen into the atmosphere right on time, right on schedule, with landing planned about 10 minutes and 50 seconds from now. Reports now from the landing site from the Antonov 26 command and control flying aircraft indicate that the crew is in great shape. They've reported everything is nominal on board the Soyuz. Descending through a cloudless sky on a Saturday morning in Kazakhstan, Soyuz MS-17 with Rubins, Ryzhikov, and Kudzverchkov aboard. The Soyuz altimeter soon to be activated to measure the distance between the Soyuz and land and the rate of descent. All that information being fed into the Soyuz computers that will trigger the soft landing engines firing just milliseconds before touchdown.
Copy. Altitude 3890.
The beeping sound you hear is a radio beacon on the Soyuz spacecraft that is relaying its position back for telemetry on the ground. The Soyuz very stable. The winds are virtually non-existent on the ground at the landing site, according to the latest reports. Russian Mi-8 helicopters with the search and recovery forces and the embedded NASA personnel are now circling the landing zone, preparing to touch down in sequential fashion within minutes after the Soyuz lands. descends, those search and recovery forces maintaining good two-way communications with the crew on board.
Altitude 500 meters. Control altitude. Standing by for landing.
In the descent module, the three crew members have cocked their seats in the landing position, tightened their straps against their Sokol launch and entry suits just a bit tighter as they prepare for touchdown.
We're ready?
Sandwiched between the launch of a Soyuz vehicle and next week's launch of a SpaceX Crew Dragon vehicle, Soyuz spacecraft is minutes away from touchdown on the steppe of Kazakhstan.
Copy. And
Copy, I confirm 1,000 meters. Copy. 500 meters. Crew, get ready for landing.
Everything looking good. Touchdown confirmed at 11:55 p.m. Central Time, 12:55 a.m. Eastern Time, 10:55 a.m. in Kazakhstan on a Saturday morning. After 185 days in space and a mission spanning 2,960 orbits of the Earth and 78.4 million miles, Kate Rubins, Sergei Ryzhikov, and Sergei Kudzverchkov are back on terra firma. At this point, the Russian Mi-8 helicopters with the search and recovery forces in tow will begin to descend one by one, first to erect an inflatable medical tent nearby the capsule, and then begin the process of extracting the crew. Confirmation now being received from the search and recovery forces that the Soyuz MS-17 landed upright, so the crew will be extracted from the top hatch on the Soyuz once a ladder is erected alongside the spacecraft.
The crew's 6-month mission on station included work on over 200 scientific experiments, focusing on biology and biotechnology, as well as physics, material science, and earth science experiments. They also welcomed the SpaceX Crew 1 Dragon 2 team and undertook 2 spacewalks to install new lithium-ion batteries, replacing the old battery storage system. This is Spacetime. And time now to take a brief look at some of the other stories making news in science this week with a Science Report. A new study has found that the risk of rare blood clotting known as cerebral venous thrombosis following COVID-19 infection is around 100 times greater than normal and several times higher than what it is following vaccination or following influenza. The research, which is yet to be peer-reviewed, suggests that cerebral venous thrombosis is more common after COVID-19 than after a COVID-19 vaccine jab from either the mRNA or adenovirus vaccines. Meanwhile, a report in the Lancet Medical Journal has found that young people are still at risk from catching COVID-19 a second time, despite previously infected people being 5 times less likely to catch the virus again. The findings are based on a study of 3,000 young US Marine Corps members, which found that 1 in 10 who had previously caught COVID-19 caught the virus again, while half the participants who had not caught the virus still tested positive during the study. Some 3.1 million people have now been killed by the COVID-19 coronavirus, and some 150 million have been infected since the deadly disease first emerged in Wuhan, China, and was spread around the world. In a case of clearly not having seen the movie Planet of the Apes, researchers have injected human stem cells into primate embryos, creating human-monkey hybrid chimeric embryos, which they then successfully grew for up to 20 days. While providing a clear ethical challenge for society, the chimeric embryos reported in the journal Cell could be used to study early human development and model disease. They could also be used for drug screening and as a way to grow spare organs for transplants. Researchers injected 6-day-old monkey embryos with 25 extended pluripotent human stem cells, which have the potential to contribute to both embryonic and extra-embryonic tissues. After a day, human cells were detected in 132 embryos, and after 10 days, 103 of the chimeric embryos were still developing. Survival, however, soon began declining, and after day 19, only 3 chimeras were still alive. Importantly, however, the percentage of human cells in the embryos remained high throughout the time they continued to grow. Researchers performed transcriptome analysis of both the human and monkey cells from the embryos, which showed several communication pathways that were either novel or strengthened in the chimeric cells. Researchers now want to undertake a more detailed study of all the molecular pathways that are involved in this interspecies communication to determine which pathways are vital for the developmental process. Archaeologists have uncovered a 3,300-year-old lost city in Egypt's southern province of Luxor. The ancient city, known as Aten, was founded during the reign of 18th dynasty pharaoh Amenhotep III. The discovery is being hailed as the second most important archaeological find in Egypt since Howard Carter's discovery 100 years ago of the tomb of Tutankhamun in the Valley of the Kings, where he uttered those immortal words when asked what he could see in the tomb, saying, "Wonderful things, and everywhere, the glint of gold." So far, Egyptologists have uncovered city streets flanked by houses with walls up to 3 metres high. Archaeological finds include rings, scarabs, coloured pottery vessels, and mud bricks bearing seals of Amenhotep III's cartouche, which help to confirm the city's identity. Historical references say the city included 3 royal palaces of Amenhotep III, as well as an industrial centre and the empire's administrative headquarters, which was all protected by zigzag security walls with only one single entrance. The public are being encouraged to cut through any loops or rings of any size in trash before disposing of their garbage, after a new study found that platypus have become entangled in all sorts of discarded items. A report in the Journal of Australian Mammalogy says items recovered from dead or rescued animals included elastic hair ties, fishing lines, and hospital identification waistbands. There was even an engine gasket and a plastic ring seal from a food jar. All of these items had cut through the skin and underlying tissue of rescued platypus. Researchers estimate that some 1.5% of all platypus in metropolitan areas and up to 0.5% of those living in regional areas are now at risk of entanglement-related injuries or death. Families with kids on the autism spectrum are being targeted by con artists flogging fake cures and treatments. Autism is a condition that affects about 1 in 75 people. It affects how a person thinks, feels, interacts with others, and experiences their environment, and can range from a very mild affliction to a profound disability. Tim Mendham from Australian Skeptics says a parliamentary inquiry into autism has heard submissions about how debunked treatments are being peddled as cures by con artists.
Parents are worried. They often don't know how to respond, how to handle the situation with autistic kids on whichever degree of the spectrum they happen to sit. But there are plenty of people out there who are willing to offer cures and treatments and whatever. Snake oil salesmen who have been around since time immemorial. And in this particular case, in this century, things such as bleach enemas, diets, obviously, pills of whatever sort, some of them toxic, various therapies. I mean, you might as well go back to dunking people in water or whatever, the variations over the years, but there's still a lot of snake oil salesmen out there very happy to take advantage. Some of them might be sincere. You'd think that they actually believe that these things cure or can treat conditions such as autism, but no, they can't. So as soon as one treatment is knocked off its perch, another one will pop up again, unfortunately. You just got to try and teach people that autism is a thing and there may not be a cure as such.
And the other thing, of course, is autism is so varied. That's why they call it the spectrum these days, because some people can have profound handicaps, while others can go on to become major scientific world changers. I mean, there's a strong belief that Isaac Newton had autistic tendencies. Einstein, certainly. It's such a wide gamut. You won't find 2 people with autism that are identical. The symptoms, the qualities are different in everyone.
It's unfortunate that there are these areas where, autism is one of it. There'd be a whole lot of other sort of standard sort of diseases and conditions of one sort or another where there's someone sort of peddling a cure somewhere. And some of them, quite frankly, might kill the patient. So parents and anyone else have to be very, very careful about these things.
That's Tim Mendham from Australian Skeptics. That's the show for now. Spacetime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. Spacetime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the Spacetime store for a range of promotional merchandising goodies, or by becoming a Spacetime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more Spacetime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our Spacetime YouTube channel, and on Facebook, just go to facebook.com/Spacetime with Stuart Gary. And Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.